Alright guys, here we go. Distance learning day. Hopefully get you in and out in 15 minutes or less. So here we go. First thing is I need you guys to open up Notability and create a new note. I want it in this format, last name, first name, and then you can put distance learning day or DLD, whatever you want to do there. You're going to use that note for notes and practice problems, all of which are going to be submitted as one document on campus. Some things really quick to go over when we're doing these distance learning days, at least for this situation, you are going to take notes. You are not allowed to take screenshots of the work. You are legit handwriting the notes in that note in Notability. They cannot be screenshots. When you're doing something like this, especially if you just have one device, you're going to need to play, you're going to need to pause, you're going to need to rewind, you're going to need to rewatch the video because I am going to move quickly through this. So going back and rewatching a problem after you've taken notes or watch it all the way through before you begin to take notes, those are different strategies that can be helpful. After you take notes, I think in this video I'm going to have 6 practice problems. Then I'm going to list out a few practice problems that you're going to try on your own. That's kind of like the homework. And then you're submitting all of that to on campus by the start of next class. This will be graded. So we're going to jump right into it. Here we go. So we began to talk about this in class when we're solving a trig equation. The first thing is let's figure out how many trig identities or trig expressions we have in one problem. In this one, we only have one sine theta. So we're going to isolate that. So we're going to subtract 1 from both sides and divide both sides by 2 to get that sine theta equals -1/2. From here, we're trying to find where on the unit circle is the y value equal to -1/2. So I've posted a little picture over here of the unit circle. The y value is -1/2 at these 2 spots. And again, our interval is going to be from 0 to 2 pi, including 0, not including 2 pi. So in this example, theta is going to equal 7 pi over 6 and also 11 pi over 6. So we get 2 answers here because there's 2 spots on the unit circle that have a y value of -1/2. Next up, again, we're going to realize that this has one trig expression, so we're going to isolate it. So we're going to subtract 3 from both sides and get cosine theta equals 0. From here, how many spots on the unit circle is the x value equal to 0? Our x value is 0 at these 2 spots, so theta is going to equal pi over 2 and also 3 pi over 2. Both of those are within the interval of 0 to 2 pi, and we're moving on. Number 3 is where things are a little bit different. In this problem, you should notice right off the bat that you have multiple trig expressions. So anytime you have more than one, or even if you have one being squared, it's best to set the equation equal to 0 first and then factor. Okay, so I'm going to put a little note, set equal to 0, and then we're going to factor. So this problem is already set equal to 0, and we want to factor it. So I'm going to put a little think, and I want you to think if this was 2x squared minus x, what we would do. We would take a GCF away, which is x, and we'd be left with 2x minus 1. Remember, if you distribute that, you'd get what you started with. So we're going to do the same thing here, and we're going to take a sine theta away from both terms. The first term would still have a 2 out in front, but it would just be sine theta. And the second term, if we take away a sine theta from sine theta, we're left with 1. That's kind of like a placeholder. Then we're going to set each of these parts equal to 0. So sine theta equals 0, and 2 sine theta minus 1 equals 0. We're going to solve both. So the first one, when do we have a y value that equals 0 on the unit circle. A y value of 0 happens two times at 0 and at pi. There's some work we have to do over here, which is adding 1 to both sides and dividing both sides by 2. Where on the unit circle is the y value equal to 1/2? The y value is equal to 1/2 at pi over 6 and also at 5 pi over 6. So this problem has a total of 4 solutions. Next up, tangent theta squared minus 1 equals 0. Again, notice the square. That means that we have to set it equal to 0 and factor. Here's your little side example to remember. If you had x squared minus 1, that's called a difference of squares. A difference of squares factors down to 2 binomials where we have opposite signs. So x plus 1, x minus 1. Back to our problem, this is going to factor to tangent theta minus 1 and tangent theta plus 1. It doesn't matter what order you write this minus 1 and plus 1 in. From here, you're going to set each of these equal to 0 and solve both of them individually. Add 1 to both sides, subtract 1, so tangent theta equals 1. And tangent theta equals -1. All right, so remember, tangent is our y value divided by our x value. And when we do our y divided by x, we get 1. So that means that they have to be the same number. The y and x have to be the same. So we should really be focusing at these pi over 4 increments. And which one of those would we divide and get a positive 1? Well, if we divide two positive numbers at pi over 4, that would give us 1. And if we divided two negative numbers at 5 pi over 4, we would get positive 1. Same kind of thing for the second part, y over x to equal -1, we'd have to divide a positive and a negative number, which is going to come from these two spots. So theta equals 3 pi over 4 and 7 pi over 4. So again, this problem has 4 total solutions. Next up, this one's a little bit more complicated. We have sine in multiple spots. So this is one where we have to set it equal to 0, which it's already done, and factor. So here's your little side example. This one might be a little bit easier to understand. If we wrote x squared plus 2x plus 1, if I told you to factor that, this would be a problem. Remember, we had that saying factors of c that sum to b. So what two numbers multiply to 1 and add to 2? It would be 1 and 1. So this would be x plus 1 quantity squared, because it'd be the same thing written out twice. So I'm going to show it written out twice over here in this example. It would be sine theta plus 1 times sine theta plus 1. So they'd both be the same thing. So we could really write that as sine theta plus 1 quantity squared. Okay, so I would accept either of these as putting it in factored form. And the reason I'd accept either is because when you then go and solve this, like if you wrote out sine theta plus 1 equals 0 and sine theta plus 1 equals, there's really no need for the second one. You're going to get the same answer. So it's really just solving one of them. Where on the unit circle do we get a -1 y value? And -1 y value occurs only, y value only occurs at one spot. So theta equals 3 pi over 2. We only have one solution here. All right, last but not least, here's your little side example. Think x squared plus x. They both have an x in common. We could factor that away. That's called the GCF. and we'd be left with x plus 1. So in our example, they both have a cosine, so we can say cosine theta is the GCF, and we'd be left with cosine theta plus 1 equals 0. We can set each of these equal to 0 and solve. So in the first one, when does the x value equal 0 on the unit circle? The x value is 0 at two different locations, at pi over 2 and 3 pi over 2. And in the second one, we would subtract 1 from both sides. Cosine theta equals -1. So again, when does the x value equal -1 on the unit circle? It only happens at pi. So theta equals pi over 2, and 3 pi over 2. 3 total answers. So again, I went pretty quickly through 6 different examples. I need you to have all the notes, all the work for all of those. You don't really have to have the unit circle there in your notes. It's fine without that, but all the work leading up to our final answer should be there. Now what you're going to do is try these 7 different questions. Write them out, show the work. Again, the work is set it equal to 0 for the ones that have multiple trig expressions, and factor it. The ones that only have one single trig function, you can just isolate. So I'm going to underline the ones that you can simply isolate. Those 4, get what I underlined by itself and find what it would be from the unit circle. For 4 and 5, they both factor, so you might want to look back. There's an example that looks pretty similar to that. Once you're done those 7 questions with the work, you are going to submit the whole thing to On Campus. Again, the directions for all of these would be solve and make sure it's within the interval of 0 to 2 pi. This should not take you guys that long. Finish it up, submit it before our next class, and enjoy the rest of your snow day. We'll see you guys on Friday.